Hey guys, I'm not going to go over the whole pre-lab, but I did want to go over some of the parts about reaction spontaneity and ranking which oxidizing agents and which reducing agents are the strongest. So I know there are also some questions about the balancing equations and finding oxidation numbers, and all that is going to be in similar questions are going to be in the recitation video that I posted today. So take a look at that if you have questions about that, and also feel free to email me if you have further questions that aren't answered by the recitation video. But so you're also given, in part of the pre-lab, you're given like 3 reactions, and they tell you whether or not a reaction occurred, and what those elements were, what those compounds were. I'm going to give you 3 reactions. They aren't the same reactions as what's in your video, but so let's say you have zinc and copper. Go to zinc 2 plus Cu, and a reaction occurs. Let's say you have, you have copper and magnesium. Go to Cu2 plus Mg, and when that happens, when you combine those, no reaction occurs. And then you have Mg plus Zn, magnesium and zinc. Go to magnesium and zinc. And when that happens, there is a reaction. So let's go through and first of all figure out what all these things are called. So when zinc goes to zinc 2 plus, it is, well, let's see. Okay, so it is losing electrons. Oxidation is lose, reduction is gain. What is that? Reduction is gain. That's how I like to remember oil rig. Oxidation is lose, reduction is gain. So it's losing electrons. It's becoming more positive, which is making it a reducing agent. That means the copper is an oxidizing agent, right? It's gaining electrons. It's becoming less positive. And then, so when you have the zinc goes to zinc 2 plus, if the zinc is the reducing agent, that means the zinc 2 plus is going to be the conjugate oxidizing agent, right? Since the zinc can reduce, the zinc 2 plus is able to oxidize, right? If we went the other way, it would be gaining electrons, thus it's oxidizing. Same thing with the copper. The copper is the conjugate reducing agent. And basically, we want to figure out which ones are strong and which ones are weak. So we know since the reaction occurs, there is a reaction. That means that going from left to right in this direction, it's going to be a spontaneous reaction. And remember, when a reaction is spontaneous, that means that on the left side, those are going to be stronger reducing agents and oxidation agents, respectively. So zinc is a stronger reducing agent, while copper is a stronger oxidizing agent. And then compared to the copper 2 plus, zinc 2 plus is a weaker oxidizing agent, and copper is a weaker reducing agent. Okay, and I kind of formatted these. Let's see, and then we can do the same thing for our next what's that called? Our next reaction. So copper is again our reducing agent. It is losing electrons. Magnesium is our oxidizing agent. Copper is our conjugate oxidizing agent. if we went the other way, it would be gaining electrons, and magnesium is our conjugate reducing agent. I'm going to go ahead and label these two at the last reaction. Same. I formatted these the same way, so that's why I'm just kind of going through, right? I put the M metal plus metal ion goes to metal ion plus metal, so that's why. But notice they're all in the exact same place. So like copper is first, copper is second, or copper is first on this side, magnesium first on this. So basically, yeah, actually just go through, and it's probably best to just go through and figure all these out individually, but I'm being lazy. So, since the second one, there's no reaction, that means that this is not a spontaneous reaction. It goes in this direction. If it goes from right to left, it's going to be spontaneous. Right? Because going left to right, it's non-spontaneous, and redox reactions in one direction, they're always going to be spontaneous. So, if they're spontaneous going this way, then that means that this side is going to be the strong conjugate. The conjugates in the second reaction are going to be strong, while the reactants on the left side of the reaction are actually going to be weak reducing and oxidizing agents this time. For the last one, it is given that the reaction is spontaneous, so that means that from left to right it's spontaneous, like the first one. Magnesium and zinc are strong reducing and oxidizing agents, respectively, and their conjugates are weak oxidizing and reducing agents, respectively. So, the other big thing you'll need to be able to figure out is I've given you zinc, copper, and magnesium, and of course also their conjugates, or not their, in some cases they're conjugates, in some cases they're, zinc and their ionic form, I guess. Not their, So anyway, you have the metals, you have the ionic forms, and you want to order in terms of strongest to weakest. Let's do reducing agents first. So our reducing agents are always going to be the metal. The metals, in this case, the metals are all reducing agents. So the weakest reducing, let's see. Okay. How do we want to play this? So copper is always a weak reducing agent, right? Whether it's combined with zinc. Let's see, let me change my marker there. So when it's combined with zinc, right, it's still a weak reducing agent. When it's combined with magnesium, it's a weak reducing agent. So we're going to put copper as the weakest. We're going to put copper as the weakest reducing agent. Okay. Next, so we're between magnesium and zinc. And so magnesium here is a strong reducing agent, whereas zinc is a weak reducing agent. So magnesium is stronger than zinc. So we can have zinc as being less strong than magnesium, and magnesium being the strongest. Okay, and then if we want to order from strong to weak oxidizing agents, we'll do the same thing. So let's see, we see copper 2+ here is a strong oxidizing agent. It's also a strong conjugate oxidizing agent in this reaction. So against both zinc and magnesium, copper is strong. So copper is always going to be the strongest Cu2 plus, sorry, not copper, is going to be the strongest oxidizing agent. And then we have magnesium. We're deciding between magnesium and zinc. So we'll look at here. Where is zinc? So here's zinc is a strong oxidizing agent. And here zinc is a weak oxidizing agent. Actually, we don't care. There, zinc is a weak oxidizing. So basically here zinc is a stronger oxidizing agent than magnesium. So we know that zinc is the next strongest, right? And then here we have magnesium is weak against both zinc and against copper. It's a weak oxidizing agent, right? So magnesium goes last. So that's kind of the biggest thing you need to know for, like I said, the pre-lab. Let me know if you feel free to email me if you have any questions about something I didn't go over. Thanks for watching.